Welcome to the Web Security Bootcamp channel, to the third part of our series, SQL Injection for Beginners. Today we're diving into something that sounds technical but has real-world consequences: SQL injection. If you've ever used a login form, you've touched a place where these attacks can happen. In this video you will learn what SQL injection is, how attackers use it, why it's dangerous, and how to prevent it in your applications. Before we start learning about SQL injection, let's learn about ethical behavior. Ethical conduct notice. This tutorial is intended solely for educational purposes and authorized penetration testing. Engaging in any form of unauthorized access or exploitation is illegal, unethical, and strictly prohibited. Always ensure you have explicit written consent before conducting any security assessments. Use your knowledge to strengthen cybersecurity and always uphold the highest standards of professional integrity. SQL injection is a way hackers trick your application into executing malicious SQL commands. This happens when untrusted user input is sent straight into your SQL queries without proper filtering. Attackers can inject code into login forms by typing something malicious instead of a username or password. Search boxes by entering SQL keywords instead of regular text. URL parameters by editing the address bar in the browser to send dangerous input. If your application doesn't protect these inputs, it may pass them directly into SQL commands, giving attackers a way in. If you're not familiar with databases or SQL, I've left links in the video description to help you catch up. Now, let's move on to some real-life examples of SQL injection. Now let's take a look at how SQL injection might appear to an attacker using a web application. Imagine there's a menu search box where the user is supposed to type in the name of a dish, like burger. But instead, an attacker types in burger or 1 equals 1. This input is sent directly into the SQL query without any filtering or validation. Behind the scenes, the query becomes select star from menu items where item name equals burger or 1 equals 1 semicolon. The problem, 1 equals 1 is always true. So instead of just returning items named burger, the database returns everything on the menu. This is a simple example of how attackers use logic to trick your application into revealing more than it should. Let's look at another SQL injection technique. This one is used to actually steal data. Suppose an attacker enters this into a product search field. Single quote union select star from users dash dash. The application expects a product name, but instead it blindly places that input into the SQL query. Behind the scenes, the query becomes select star from products where name equals single quote union select star from users dash dash semicolon. The attacker's union command combines results from two different tables, products and users. Now instead of returning product results, the database leaks user data, like emails and password hashes. This is how real attacks happen when developers don't properly filter or restrict user input. SQL injection doesn't always come from forms, it can also come through URLs. Here, the attacker modifies the URL by adding $ID equals 5 or 1 equals 1. The web app sees this and plugs it directly into the SQL query. Select star from products where ID equals 5 or 1 equals 1 semicolon. The problem is that 1 equals 1 is always true, so the condition passes for every product in the database. Instead of showing just item number 5, the app now displays everything because it believes all the rows match the condition. This technique is simple but dangerous, and it can expose sensitive data or overwhelm the application. Here's a simple SQL query used by many login forms. The application checks whether the username is admin and the password is 1234. If both are correct, the database returns the user's information and logs them in. But what if a hacker enters something sneaky instead of a real password? In the next slide, we'll see how that works and why this code is so dangerous if not protected. If the attacker enters single quotes or 1 equals 1 dash dash as the password, the application builds this SQL query. Select star from users where username equals admin and password equals single quotes or 1 equals 1 dash dash semicolon. The injected or 1 equals 1 is always true, and the dash dash tells SQL to ignore the rest. So instead of verifying a real password, the query just says, "Is this always true?" It is, and the database returns a match. Now the attacker is logged in as admin without knowing the actual credentials. SQL injection doesn't just happen in select queries. It can affect any part of an SQL statement if user input is inserted directly. In the where clause, attackers can bypass checks. In order by and limit, they can manipulate sorting or extract massive datasets. With union, they can pull in unauthorized data. But it doesn't stop there. If your app lets users update data, an attacker might inject code into an update query, like changing their own role to admin. Or in an insert query, they could inject a malicious string disguised as a comment. If user input isn't filtered or parameterized, any part of your query is vulnerable. If your application is vulnerable to SQL injection, the consequences can be serious. Attackers can log in without a password, gaining unauthorized access to your system. They can steal sensitive user data, including names, emails, and password hashes. They may also modify or delete data in your database, changing prices, deleting accounts, or planting fake records. And in advanced cases, SQL injection can be used to take control of the entire server, leading to full system compromise. These risks are why SQL injection has consistently ranked among the most dangerous vulnerabilities on the web. The good news is SQL injection is preventable. First and most importantly, always use prepared statements, also known as parameterized queries. These separate user input from SQL logic, making injection impossible. Second, never insert raw user input directly into your SQL strings. Always sanitize and validate input, especially anything coming from forms, URLs, or query strings. Third, use modern frameworks and ORMs, object relational mappers like Prisma, SQLize, or Django ORM. These tools are built to protect you from these vulnerabilities by default. Finally, keep your database drivers and libraries up to date to benefit from the latest security patches. A few best practices go a long way toward protecting your app. Now it's your turn. I've got 3 quick questions for you. Name 2 places in a web application where SQL injection could occur. What's one method to prevent SQL injection? And finally, what's the most interesting or surprising thing you learned in this video? Share your answers in the comments. I'll pin some of the best ones so everyone can learn from each other. Let's review what we covered in this video. You learned what SQL injection is and how it works. We looked at where injections can occur inside a SQL query, not just in the where clause. You saw real examples including login bypasses, URL-based attacks, and even extracting data with union. We talked about the risks, from unauthorized access to full system compromise. And finally, we covered how to protect your applications using prepared statements, input validation, and modern ORM frameworks. In the next video, we'll move from theory to practice, with real-world SQL injection labs using PortSwigger Web Security Academy. Before we dive into real-world labs, you'll need to get your tools ready. First, register for a free account at PortSwigger Web Security Academy. This will give you access to interactive SQL injection labs in a safe, legal environment. Second, download and install Burp Suite Community Edition. It's a tool we'll use to intercept, inspect, and modify web traffic during our tests. Both tools are completely free. The links are on the screen and in the video description below. In the next video, we'll walk through using them step by step. Join me there. Thanks for watching. If you found this video helpful, be sure to like and subscribe for more beginner-friendly content on cybersecurity and ethical hacking. And don't forget to check the video description for all the links we mentioned. If you have any questions or suggestions, please write them in the comments. See you in the next one, where we'll jump into our first real SQL injection lab.